Okay, so here we are, tips and tricks. We're very fortunate to have the opportunity to go through the second mini project. This is an exciting project because the data set is very nice and the techniques complement nicely with what we've done with Lab 7. So we have our esteemed expert, Michael here, a STEM fellow who will lead us through some content, but be sure to ask some questions as we go along. And our hope is for it to be interactive enough that you can kind of follow along. For those of you viewing the video, will have the chance to stop and start and learn something and inform your work. So without further ado, I'll turn it over to Michael. So great.
All right. Hey, everyone. I'm Michael. So I'll start here at the top. I'm just going to import everything that we need to import to look at the data. And I'm using the data that's going to actually be in the mini project. So there's pretty much two data sets that we're going to look at. The first data set is just going to be the plot description. And I guess just a quick overview as far as what a plot is. A plot is just going to be like the 9-meter radius with in a particular region. So there's going to be multiple 9-meter radius plots that we have the opportunity to look at. So the first data set is just going to be our plot description. So you can see we have the different names, or I guess what's showing right now is the one name, but we'll see all of the different plot names in just a second. But I guess the importance here is that this is just the description of the plot. So we have things like longitude and latitude of the area, the impact type, our aspect, which gives us, is it north, northwest, or so on and so forth. And then the second data set that we're looking at is the annual data for each plot. And this is the this data set is actually one that I'm going to be more so going over for this example. So I named my variable yearly data because we're looking at this here. This is the data set that we're looking at. And so if we move down to this cell, I'll run this. This line actually gives us all of the names of each individual plot. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It looks like 13 plots if I counted that right. Each of these plots, again, just to reiterate, is a 9-meter radius region that's around the volcano that erupted. And so from that, we're going to we can randomly choose one. Does anybody have a preference, or should I just choose one for the sake of our example? You can just say it, or I guess I'll just choose the example that from the lab. They already have the STRD, so I'll just go with that example. Let's see. So we plug that in here. Don't forget your quotes because it will throw an error otherwise. And now we'll run that cell just so we have it. And now I think that this is sort of important when it comes to keeping track of information. I think it's important to be careful how you name your variables. So for instance, we could just name this variable data, but the data that we're looking at is going to be the data we just chose the STRD table. So it might be good to name your variables, let's say data STRD, because I think you have to look at multiple plots for this assignment. So be a good way to just keep track of what plot you're actually looking at. So let's do that, and we'll run that cell. And you can see the plot name that comes up is the STRD data. So again, just naming your variables, I think you have to use the data for multiple questions. This way you don't have to run and go look back up at the question like, oh, what did I plug in here? It's sort of, you know, just makes it a little more simple. So now we're looking at the data for the STRD table. I'm gonna just copy and paste this again down here because this is the data that we're looking at. And I wanted to take the opportunity to go over the group function. I know that you guys have already used this in a couple assignments, but sometimes hearing the same information multiple times, you hear it for the third time, you're like, oh, that makes sense. So if this is repetitive for some of you, I apologize, but pretty much the group function, if we look at this, we're grouping by year here. So that means for this particular plot, in the year 1984, we're going to have 10 rows, and so on and so forth. So 1994 is going to have 20 rows of information. And so also what I wanted to show is when we add this second parameter to the group function, the np.mean, which most of you I'm sure already know, that just gives us the mean. But when you add it to when you add this second parameter to the group function, what comes back is, let's see, maybe is it because of that?
Exactly.
Let's try that. Okay, that's a little better. So what this actually does is, we saw, I think 1984 had 10 rows of information. What this does is it consolidates those 10 rows and we're going to get the average for each. So for instance, if we look at the richness mean here, we see that we have a 0.6. If we go back and look at this table, this is really easy to convert because there was 10 rows and that's what's showing here is 10 rows. So these are all of the rows for 1984. And you can see we have 2 and 1, so that's 3, and then we have 2 and 1 here, which is another 3. So it's, to get the average is, I think it's 6 divided by 10, and so we can confirm here that this gave us the average for 1984. So I just think that that's something just to keep in mind, what the group function is actually doing. So we're grouping by year, but now adding that second parameter is going to give us the average. So that way, it just makes the data a little easier to look at. And so I'll show you what I mean down here. Something here, we have richness and the coverage percentage, and we have the H prime. For the rest of the example, I'm pretty much going to be looking at the H prime. I believe for the mini project, you guys will be working with the richness and the cover percentage. H prime, I think, is the biodiversity of the regrowth of after the volcano erupted. So yeah, we'll be looking at the biodiversity. And again, here I have this ellipsis here because I just wanted to drive in the point. Data, but what data are we looking at? And again, we're still working with the STRD data for this example. And so when I run this cell, we have the year here at the bottom, and then we have the H prime mean on the sides. And let's say the year is, let's say 1990s. Does that show? Okay, 1990. H prime for the year 1990, 1.6168. And so that's going to be like what we're looking at right here. And that's also the importance of average, because 1990 could have multiple data points, but it wouldn't be really useful to see a data point here, a data point here. This just makes it easier to look at. All right, going down here, let me just copy and paste the STRD one more time. Still looking at the STRD data. I'm just going to fill this in everywhere really quickly. Sort of everywhere I see data. This way you guys can just see like how much you're using the data and like why, it's important to like mark what you're looking at. So I defined, we have the year min. This is going to pull, we started, I guess, collecting data the year 1984 for the STRD data. And then the max year we have 2009. So for this particular plot, the STRD plot, it's been plotted from 1984 to 2009. That's the data that's been collected annually. And now I also defined for the max year mean and then the min year mean. We see that here, and then let's run that there. And what we're going to use our year max mean for and our year min mean is we're going to find the diff means, which you guys, I believe, use that in lab 7 because it's how you need the diff in the means to find your t-value. So we're going to be using that information here. I went ahead and just created a function to find the diff means, just to give you guys a variation. You could just write out diff means equals and then do this here minus this here. But again, I think that making it more simple for yourself to look at and to understand what's going on, it might be nice to put this in a variable. And again, like I just created a function here. The function is going to take in 2 different year means. So in our case, well, I guess I'll go over that in a second, but just to go over this function, it's function find diff means. We pass in 2 different means for 2 different years, and the result is going to be year 2 minus year 1, whatever you pass in, and we'll return that result. So here's where I'm defining diff means, and we're going to pass in our 2 parameters. Just to, if anybody wants to chime in, does anybody have a guess or suggestion for what would be appropriate to pass into our diff means function, our find diff means function? And if not, that's fine, but I wanted to just give you guys an opportunity.
Anyone there?
All right, so what we're going to be passing through here are the 2 variables that I created. So we have our year max mean, and then we have our year min mean. And the idea of creating a function versus just, typing everything out mathematically is like, if you guys are going to be using the diff means over and over again, it might be better to just put it in a function to, again, to simplify it for yourself. So this, oh, I don't think I ran this yet. So now this should work. Let's see. Okay, yeah, it worked. So our diff means is 1.554, and then all of these other numbers. And let's see again. The data shows up down here again. And this whole time I'm just looking at this one plot. So it looks like one more location. And I think it's a good practice to copy and paste as much as you can, because it just helps eliminate any potential errors. So you'll see that like anytime I wanted to copy STRD into my data, I always use copy and paste. All right.
Okay, so now we'll see that we may actually need to do an independent sample t-test because of the 20 and 10 available pieces of data. So to do this, you can look here and see, and you can go back and review some of the details in the mini project. But here we can see our difference of mean, and then we can pull out our t by difference of means divided by the standard error. And then we can see the t-test will use 16.35, and as we go down, we will see our p-value is 0.01.